Okay, this is AP Calculus Lecture 5.8a. In this lecture, you will want to have your unit circle handy. And this lecture really doesn't involve any calculus. We're just going to review some trigonometric concepts from pre-calculus. And we'll be on page 383 in your book. So when we're talking about inverse trig, for example, we call arc sine, arc cosine, arc tangent. The way that you may have seen this written before, especially in like a physics class, is sine raised to the -1 or of x. Okay, so but that can mean a lot of different things, and a better way to say it is probably to use the term arc sine. But what that means is the angle whose sine is x. If you're taking the inverse sine or arc sine of x, your answer is going to be an angle. Now we want to review our right triangle trigonometry, going all the way back maybe to your geometry class, and maybe you learned the acronym SOHCAHTOA, and that is sine is opposite over hypotenuse in a right triangle, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, so that's all within this acronym. All right, the reciprocal trig function, so for sine that would be cosecant, and you just flip sine, it's hypotenuse over opposite. For cosine that would be secant, hypotenuse over adjacent. For cotangent, flip tangent, adjacent over opposite. Now when you're thinking about the unit circle, we use an acronym all seniors take calculus, ASTC. So all trig functions are positive in quadrant 1, only sine and cosecant in quadrant 2, tangent and cotangent in quadrant 3, cosine and secant are positive in quadrant 4. You also have some restrictions on the angles that you can report, or the answers that you can report for inverse trig functions. Sine, or the inverse sine or arc sine, is restricted to quadrants 1 and quadrant 4. So between -pi/2 and pi/2. Okay, otherwise it fails the vertical line test to be a function. Arc cosine is restricted to quadrants 1 and 2, so 0 to pi. Those are the angles that the restriction holds. And then arc tangent is restricted from -pi to pi/2 to pi/2. So again, basically -90 degrees to 90 degrees are quadrants 1 and 4. And then cosecant, secant, and cotangent all follow those same rules. All right, so have your unit circle handy. Pause the video if you need to continue to write any of this down, and then we'll work some example problems for the rest of the lecture. Okay, our first example problem is number 6. And this is on page 383. So we're supposed to do this without a calculator. Find the arc sine of 0. Okay, so on your unit circle, okay, the way it reads is cosine and then sine. So 0 radians, sine is 0, and that does fall within the quadrant 1 and quadrant 4 restriction. But you also have sine at 0 at pi, and pi falls outside the restriction. Okay, so the angle whose sine is 0, arc sine of 0 is 0. And that's also true for pi on the unit circle. However, since pi is outside the restriction, then we can only report answers between -pi/2 and pi/2. All right, so we can only report those, so the answer is 0. Let's look at example 8. All right, and that is arc cosine of 0. So if you look at the unit circle, the angle whose cosine is 0, you will see that it happens in two places on the unit circle, at pi over 2 and at 3 pi over 2. However, cosine, the angle restriction is between 0 and pi, so we can't report 3 pi over 2. We can only report pi over 2. So I'm going to circle pi over 2, but I'm going to put an X right out 3 pi over 2. Put an X through that because it's outside the restriction. Let's look at example 12. So that says find the inverse cosine. So just using different terminology than arc of negative root 3 over 2. All right, we'll take a look at the unit circle. Where is cosine negative root 3 over 2? Remember, cosine comes first. Okay, so it happens here in quadrant 2, right there at 5 pi over 6, and again in quadrant 3 at 7 pi over 6. However, 7 pi over 6 is outside that 0 to pi restriction, so the answer is 5 pi over 6. All right, I'm just going to box that one in as the answer and cross out 7 pi over 6 just to remind you not to report that one. All right, let's look at example number 20. Okay, so in this one we're taking the tangent of the arc cosine root 2 over 2. Okay, so first of all, we want to work inside out. So the arc cosine, this is part A, by the way. The arc cosine of root 2 over 2, if you look on your unit circle, angle whose cosine is root 2 over 2 is pi over 4. So let's plug that in, pi over 4. All right, so tangent is equal to sine over cosine. So that's going to be the sine of pi over 4 over the cosine of pi over 4. Now again, I couldn't put the fourth quadrant 7 pi over 4 answer because it's outside the restriction. So that's going to be root 2 over 2 divided by root 2 over 2, which is just going to be 1. A lot of students will memorize that any of on the unit circle, tangent and cotangent, if it's got a 4 as the denominator, then it's going to be 1 or negative 1. This is in quadrant 1, tangent's positive, so it'll be 1. Let's take a look at example B. The cosine of the arc sine of 5 over 13. Now 5 over 13 is not on the unit circle. If it's not on the unit circle, we need to draw a triangle. All right, the hypotenuse is 13. Opposite would be 5. If you go through the Pythagorean theorem, or maybe you've memorized this one, this is a famous angle, then our famous right triangle, then the adjacent would be 12. Okay, so we know we're in quadrant 1 because the answer is positive, so the cosine of angle theta is going to be adjacent over hypotenuse, or 12 over 13. All right, pause the video if you need to, and we will move on to the next example. All right, we are on example 22, still on page 383. Okay, that one wants us to take the secant, the arc tangent of negative 3 over 5. Now the way that I think through these, so we have negative 3/5. Now that's not on the unit circle anywhere. So let's draw a triangle. Now I'm not going to put the negatives in. We're going to use that to figure out the quadrant. So if it's negative, the only quadrants that we can report for tangents, quadrant 1 and quadrant 4. Well, tangent's negative in quadrant 4, so our answer has to be in quadrant 4. All right, tangent is opposite over adjacent. Okay, so 3 over 5. We're not going to worry about the negative. We'll fix that at the end. Now, what's the hypotenuse? Let's use the Pythagorean theorem. It's going to be the square root of 5 squared plus 3 squared. Okay, so 25 plus 9. That's going to be the square root of 34. Okay, so secant theta, again, this is part A, sorry about that. Secant theta is hypotenuse over adjacent. So that's going to be root 34 over 5. Now, in quadrant 4, what is secant? Is it positive or negative? Well, cosine and secant are positive in quadrant 4, so it's just going to be positive square root of 34 over 5. All right, let's look at part B for 22. That says the tangent of the arcsine of negative 5 over 6. Okay, sine, again, we are restricted to quadrant 1 and 4. Since it's negative, we must be in quadrant 4. Tangent's also negative in quadrant 4, so we're going to end up with a negative answer in the end. Okay, so let's draw our triangle. All right, angle theta. Sine is opposite over hypotenuse. If you use the Pythagorean theorem, this adjacent side would be the square root of 11. All right, test me out. Try it on your own. See if I did that math right. Okay. But it's going to be the square root of 36 minus 25. So square root of 11. Now tangent is opposite over adjacent. So 5 over the square root of 11. But since we are in quadrant 4, right, tangent's negative in quadrant 4, then this has to be a negative. All right, pause. I'm about to erase, and we'll move on. Okay, let's take a look at example 24. We're still on page 383. In this case, we want to take the secant of the arc tangent 3x. Okay, so, well, 3x isn't on the unit circle, so we want to draw a triangle. Tangent is opposite over adjacent, so it's going to just be 3x over 1. 3x over 1 is the same as 3x. So this would be the square root of 1 squared, which is just 1, plus 3x all squared, right? That'd be 9x squared. So 1 plus 9x squared. All right, again, that's just hypotenuse squared is equal to 1 squared plus 3x all squared. So that's where you get that 1 plus 9x squared. All right, so what is the secant of that? Well, secant is hypotenuse over adjacent. So the square root of 1 plus 9x squared over 1, which most people wouldn't put it over 1. They would just say 1 plus 9x squared and circle that. All right, number 26. Okay, this one we want the cosine of the arc cotangent of x. All right, again, if it's not on the unit circle, let's draw a triangle. Well, x isn't on the unit circle. It's not, it's not root 2 over 2, is it? Or 1 or 0 or negative 1. Okay, so cotangent is adjacent over opposite. So that's going to be x over 1. Hypotenuse then would be the square root of x squared plus 1 squared, or x squared plus 1. All right, so what's the cosine of that? Okay, cosine is going to be, we didn't even need to know the hypotenuse, did we? All right, so our, yeah, we did, excuse me. So cosine is x over, adjacent over, the square root of x squared plus 1. All right, just a couple more examples to go. And that'll do it for 5.8a. So example 40. We've moved on to page 384. So that one says solve for x. We have arc tangent 2x is equal to negative 1. We want to clear out this arctangent. And the way you do that is to take the tangent of both sides. Okay, that'll clear out that arctangent. So we'd have tangent, arctangent 2x is equal to tangent negative 1. So you want to have your calculator ready for this. Now, tangent and arctangent cancel each other out. So you would just have 2x. Okay, just cancel each other out. Your calculator needs to be in radians. Okay, so let's put calc in radians. Okay, so take the tangent of negative 1, you get negative 1.557. It's 3 decimal places. So x divided by 2, you get negative 0.779. And then finally, example number 42 is the arc cosine of x is equal to arc secant of x. Well, you could take the secant of both sides, you could take the cosine of both sides. I'd rather work with cosine than secant. So cosine of the arc cosine of x is equal to the cosine of the arc secant of x. Cosine and arc cosine just cancel out and you have x. So that was what all that work was for. But on the cosine of the arc secant, we're going to have to draw a triangle. Secant is hypotenuse over adjacent, so x over 1. Now cosine doesn't involve the opposite, so I'm not going to even try to figure that out. So cosine is going to be 1 over x. So let's multiply both sides by x. We'd have x squared is equal to 1. And then x is going to be plus or minus 1. So that does it for the example problems of 5.8a. Let me erase this and I'll write down your homework assignment. Okay, so the homework is page 383. You can do 5 through 29 odd, but skip number 17. So skip that one, but 5 through 29 odd otherwise. You can also do number 39 and number 41. All right, so I will talk to you on the next video.